Welcome back, students. The next preparation of the alkyl halide is from the alcohols. Alcohols can be converted into alkyl halide by the action of HX. HX means either HCl, HBr, and HI. HF should not taken into consideration, being a very weak electrolyte. For a given alcohol, the reactivity of the various halogen halides follows the order that with tertiary alkyl halide they are the fastest, and in the primary they are the slowest. And the reaction of the various hydrogen halide is that HI is the most reactive and HCl is the least. HF not taken into consideration because of the very low degree of the dissociation. Now what happens here in case of ROH, that is alcohol, if it reacts with HX, it is either HCl, HBr or HI. Okay, this water molecule along with this hydrogen being lost, and you have the formation of the corresponding alkyl halide. It means if you take methanol, you will get methyl chloride. If you have R here propanol, then you have propyl chloride here. So the corresponding alkyl chain is being formed here. Now look at that. The component or the reactant here is ethanol. Ethanol, when react with HBr, it produces bromoethane. Okay, the reaction can occur through both SN1 and SN2 mechanism depending upon the little bit temperature. Okay, in this case what happens, the lone pair, it attacks the H plus, that is the electrophile, because HBr being a strong acid, H plus is easily available in the alcoholic medium. So this lone pair present on oxygen will strongly attack H plus, and protonation of the hydroxy of the alcohol takes place. Okay, after that what can happen, this hydroxy can lose as a water molecule. Why? Because this bond pair will convert into a lone pair. This bond pair will convert into a lone pair, and along with that you had the formation of the carbocation, and on that carbocation now Br negative, that is the nucleophilic part, will attack. Okay, and you had the formation of ethyl bromide. Now this is via SN1. The same reaction can take place by SN2 mechanism also, that after the protonation the X negative part can attack from the behind to give you the corresponding alkyl halide. Okay, we will discuss SN1 and SN2 in detail after a while. Now next is Groos process, that is actually extension of the reaction of the HCl. Okay, in this case what happens, in this case the primary and the secondary alkyl halide are prepared by passing HCl gas through a suitable alcohol in pans of anhydrous ZnCl2. The purpose of using ZnCl2 to help the cleavage of carbon oxygen bond of the alcohol, being a Lewis acid. Why? Because zinc has the availability of vacant orbitals. It coordinates with the oxygen atom to the other alcohol, so the carbon oxygen bond becomes weakened, and that carbon oxygen bond becomes weak and it breaks down, and the formation of carbocation can occur very easily. Look at that. This is HCl gas. Okay, in presence of anhydrous ZnCl2, it gives you chloroethane and water. With 2 propanol, it will give you 2 chloropropane. In case of tertiary alcohol, that is very interesting point. In case of tertiary alcohols, anhydrous ZnCl2 is not a necessary requirement. You may use that, but it is not necessary. Concentrated HCl is enough to cause the reaction. Why? The reason being that tertiary carbocation is highly stable due to hyperconjugation and due to inductive effect. So both hyperconjugation and inductive effect, they promote the formation of the tertiary carbocation. So that's why in case of tertiary carbocation, in fact, no ZnCl2 is required. If it is used, it can only speed up the reaction, but actually it is not required as such. Are you sure about that? The same process is more popularly known as the Lucas test for various types of alcohols. Okay, in that you have to understand that here in all these cases what is happening. Okay, the alkyl. Look at the mechanism of this case now. Now alcohol oxygen, the lone pair attacks zinc because it has vacant orbitals, and now what happens? A covalent bond has been formed here. Now what happens? A covalent bond is formed between oxygen and zinc, and after that what happens? This bond is broken and the bond pair becomes lone pair. So this R becomes a carbocation and you had the formation of this compound. After that what happens that after the formation of cation, the nucleophile can attack the carbocation because carbocation being trigonal planar in nature, the nucleophile can attack from top as well as it can attack from the bottom of the molecule. Okay, sure about that. We will discuss this later on when we discuss the nucleophilic substitution. So the carbocation is trigonal planar, so nucleophile can attack from top as well as from the bottom. Now along with that you can use HCl plus H2SO4 also, or you can use HBr plus little bit of H2SO4 also. So that can also be used so that you can able to do that. Sorry, here KCl in H2SO4 and KBr in H2SO4 can also be used because when they react with this they will give you K2SO4 and what they can give you the formation of HCl and K2SO4 plus formation of 2HBr. Now Ki cannot be used here. The reason being that iodide ion that is formed can be oxidized to iodine by H2SO4. That's why Ki and H2SO4 is not used. So what can be used in place of H2SO4? In place of H2SO4, one can use phosphoric acid. One can use what? Phosphoric acid. Okay, then it can be done. Sure about that or not? Are you okay with that? Why? The reason being that phosphoric acid is not an oxidizing substance. You can say powerful oxidation. Okay, sure about that? If someone wants to use, someone want to use HI directly, then what can happen then? Refluxing is required. Under normal condition, that is not possible. What is refluxing? It is the process of heating. A liquid in a flask with a condenser so that vapors are condensed back into the flask. Okay, sure about that? So you can say it may also called as what? It may also called as constant boiling. It is also called as what? Constant boiling. Sure about that? If you want to use what? HI directly also. Let us suppose you can take an alcohol and use HI directly. Okay, that is called reflux. Okay, sure about that? Sure about that or no? So what will happen? You have the formation of iodoalkane. Here R is what? Here R is R2CH5. Similarly, if you have an alcohol and react with KCl in presence of H2SO4, then you have here HCl. Okay, why? Because KCl with H2SO will give you HCl. Or if you treat with KBr in H2SO4, then also you will get the same product. So please memorize this point very well, that KBr in H2SO4, I am repeating once more, KBr in H2SO4 and KCl in H2SO4 can be used what? Can be used as chlorinating agent and fluorinating agent respectively. Are you sure about that? That is very, very important. Now we have to look the reaction of alcohols with what? We have to look at the reaction of alcohols with PCl5 and PCl3. PCl5, PCl3, or with thionyl chloride, in that we will discuss the mechanism in SNI, that is nucleophilic substitution internal. Okay, what is that? Nucleophilic substitution internal. In detail we will discuss there only, but here we will discuss only what? Here we will discuss only the preparation part. Okay, when alcohols, when they react with PCl5, you had the formation of alkyl halide along with phosphorus oxytrichloride and HCl. Now what is happening here in this case? Okay, this alkyl halide obtained and this POCl3 formed, they are very difficult to what? They are very difficult to separate. POCl3 is very much difficult to separate. Okay, very much difficult to separate. So you can see here that POCl3 is very difficult to separate. Okay, sure about that? Now if we use PCl3, then what happens? If we use PCl3, then also in that case you have the formation of phosphorus acid along with the alkyl halide. Now this phosphorus acid is also very difficult to separate. So both PCl5 and PCl3, will give you certain side product which are very difficult to separate out. Now look at this. This is 2-propanol. This is also 2-propanol. If it react with PCl5, it will give you what? It will give 2-chloropropane. With PCl5 also give you 2-chloropropane. So what is the difference? The only difference being is the side product. In one case you are getting POCl3, in the second case you can get H3PO3. Now similarly, in case of bromoalkanes and iodoalkanes, they can be prepared by using the action of PBr3 and PI3. Okay, how could you prepare PBr3 and PI3? If you treat phosphorus with bromine and phosphorus with iodine, you will get both PBr3 and PI3. Remember that both PBr3 and PI3 are not very stable compound, and generally wherever they have to be used, they prepared in solution there only. Okay, so you can say that here in the solution itself PBr3 is formed and transformed into a product. So similarly you will get phosphorus acid in each case, but in one case you are getting what? Bromopropane, and in the second case you will get the corresponding iodoalkane. Are you sure about that or not? So you have to memorize that here in this case, that both PBr3 and PI3 gives the same reaction as given by PCl3. Okay, so look at that, side product is same, that is H3PO3. So in all three cases you will get phosphorus acid as one of the byproduct. Now we have to take the use of what? The use of what? The use of SOCl2. That is called as what? That is called as thionyl chloride. This compound is called thionyl chloride. Now what happens here, that if you take an alcohol and react with thionyl chloride, okay, and that should be in pyridine, then what happens? You had the formation of alkyl halide along with evolution of SO3 and HCl. Now both SO2 and HCl are gases. They are what? Gases. So gases, what happened to gases? Gases can be easily what? Gases can be easily vaporized. Gases can be easily vaporized. So they leave the system. They leave the system immediately. So you can get what? Alkyl halide as one of the product. Alkyl halide as one of the product here. Are you sure about that? Okay, and I told you already that it follows SNI mechanism, which I will discuss later on. Okay, so you can say that the reaction preparation method with SOCl2 is preferred method in comparison to HCl, PCl3 and PCl5. These are not preferred method, but SOCl2 thionyl chloride use is a preferred method. Why it is so? Because all the byproducts obtained here in this case are gases. So you can say that alkyl halide is absolutely obtained in the almost pure state. So look at that, what happens here, that CH3 CH2OH when react with SO2 in pyridine. The same reaction can also be take place in ether also. Okay, so you had the formation of Cl2 along with formation of SO2 and HCl. In case of pyridine, inversion of configuration happen, and in case of ether, retention of the configuration happens. So remember that, I am repeating once more. In case of pyridine, what happens? Inversion of configuration happens, and if ether is used as a solvent, then you have retention of the configuration. Happens. Now in this case, in Schwarz reaction, direct fluorination of alkanes is not possible due to the explosive nature of the reaction. Why? Because fluorine bond energy is low and CF bond energy is large, and reaction is highly exothermic in nature. The CF bond energy is greater than that of the bond energy of carbon-carbon bond. So fission of the molecule into smaller fragments is possible. Okay, so that's why direct fluorination is avoided. Direct fluorination can be possible if we dilute the fluorine by adding a much more larger amount of nitrogen or argon. Alkyl fluorides are conveniently prepared indirectly by heating with suitable inorganic fluoride like arsenic fluoride, antimony fluoride, cobalt fluoride, or silver fluoride. And all these inorganic fluorides, their nature is covalent. Okay, sure about that? So they have low ionic nature and high covalent nature. Sure about that or not? Clearly understood now? Now look at that. If you have methylamide react with AgF, then you have formation of fluoromethane plus you had formation of AgBr. Similarly, if you have chloroethane, plus you had formation of Hg2Fe2, what happens? You had the formation of fluoroethane and plus formation of mercurous chloride. Okay, this is known as Schwarz reaction. Okay, but if you had on one carbon, okay, two or more than two halogens are present, like in case of germanium dihalides, then the cobalt fluoride and antimony fluoride, they are more suitable than what? They are more suitable than the other halides. Let us suppose what I am trying to say, if you have two chloride here, then either COF3 or antimony fluoride, they are better to do the fluorination than the other covalent fluorides. Sure about that? This is known as what? This is known as the Schwarz reaction. This is known as what? Schwarz reaction.